Okay, now what I'm going to do is give you a small task over here where you have to write the corresponding.
Excuse me, can I ask you a question?
Yeah.
The head and tail always like empty, or we can assign number to it?
In the There are two kinds of implementations. I mean, you can use dummy nodes, you cannot use dummy nodes. So dummy nodes are something where you just have some extra nodes only specially for head and tail. That's called a dummy node implementation.
When we do the dummy node implementation, do we have to declare those in the class separately before we can create the list?
This you're talking about the code?
Yeah, I imagine we would have to create those two nodes first, and then we would put the other nodes in between them.
Exactly. Those two nodes, the dummy nodes are created exactly in the same way as any other node. Only thing is how subsequent nodes are being added define the list. So if you look in the dummy nodes implementation, it actually makes it easier to actually add another node, because every time adding a new node looks like adding something between two existing nodes. Only thing is, like internally in the program, even if you have some data items stored over here, you're typically ignoring it because you're always beginning with heads next. It's an understanding that these nodes are just placeholders simply for head to point to it. Their data is technically not a part of the list. The data will just begin over here, just between these two nodes. It's just to make the coding easier by wanting to add the node, any subsequent node, and not having to update the head and the tail every time. Because if you look in the singly linked list that is without a dummy node implementation, you will see that there are several checks. Are you adding at the head? If you are, then you are updating the head. But in this particular case, this case will be treated as adding a newer node into any existing uh, two nodes. That's just a very general case. When we add any node between any two nodes, like these two nodes, if I want to add a new incoming node, I'll just put them over here because I have a pointer to this node. Adding between head and this case would actually be the similar as adding between these two nodes, and same case. That's why you have these begin with, when an empty list, you will always have these two nodes already set like this. That has been already set in the code.
So when we use the commands prepend and append, those in the class are taken care of. And actually, when we do prepend, it places it in the second spot, right? Not in the
here, yeah.
Okay. And then the append would put it right before the tail?
Yes, every time, yes.
Okay, cool.
Hold on. Yeah, so then prepend will put it in between these two. A subsequent append will put it here. A subsequent prepend put it here. Subsequent append here. Subsequent prepend here. Technically, think of these head and tail just expanding and moving to make place of newer nodes in there. Right?
Okay, cool. Yeah, okay, that's clear.
Okay. It's just for the code to be written simpler versus when we actually envision it, it's no different from what we just saw with the singly linked list. And a prepend is over here, an append is over here, again a prepend over here, an append over here. That just keeps happening. Technically, when we are writing the code, we have to make those checks that where are we adding, what are we doing? Because if we do a prepend, we have to actually update the head every time. But in this case, you're simply not updating the head. You're just saying, okay, put it between the head and the first node, right? The head will always stay at the dummy. That's what making the writing of the code easier versus anything else. So now this task is in this class now. to translate this left to right. So mostly if our list had 173, if this was the list, this code prints out, because it's left to right traversal, prints out 173. This one 371, reverse. Translate, write the equivalent left to right traversal for the doubly linked list with dummy nodes, but write the recursive version of this particular thing. Write the recursive version of this particular thing. Okay, so I'm going to now divide you into groups, give you about 15 to 20 minutes. Just write the recursive equivalent. Group 1 will write the recursive equivalent of traverse for a doubly linked list with dummies. What the goal is to be able to print left to right. And the group 2 will be able to print right to left, but again, the corresponding recursive version of it. Right, so let's do that now. And do you have any questions? So let's do that now. I'm going to divide you into groups, and this division is just random. The Zoom just randomly chooses the participants, and I don't choose which people go into which room. So do you have any questions? The question is clear, right? The goal is clear. Let me also write it in the chat, the goal of the question, or what you have to achieve. Hold on. Header files. I need to place these header files in my project folder. So I have downloaded the master files from the GitHub, the code master from the GitHub in my folder here. So I'll go there. I'll get the dlink list HPP and the dummy node dlink list HXX, these two files. I'll simply copy them, Control C, and then bring them to this project here, DLL new project, paste them over here. Once that is done, then I right click on the header files, click existing item, and select this dlink list HPP. Again, right click on the header files, existing item, select the dummy nodes dlinks HXX. These two are now added over here. And now I will double click both of my HPP and HXX over here, right before my iterator function definitions is where I can begin writing my code. So for example, if I were to write the iterative version, I can take the traverse and print function from the Titanium. I can simply, so for example, this is a function that I want to write. So I will actually, just for an example, here is where you're writing your new function. So this is a ready-made function that we have taken from Titanium, but your new function would be on these lines where you'll be writing more code over here. Just remember that your function looks something like this, and then you will have to add the header file into the HPP so that you are able to use that function. So let me add sorry, not the header file, just the header of the function, which is this one. Then you are able to actually call this function to test it if it is working correctly. So another thing that you have to do in the HPP, we have to activate the dummy node HXX. So I have to comment out by default that is activated. I have to comment out this one and uncomment out this one. So you have this version that is actually the result of the traverse function. So what you have to do now in the HXX over here, given the header that I have put in the chat, you would have to have a function. So for example, that header looks similar to this one. I'll start writing my corresponding recursive version over here. Call it anything you like. I mean, print R forward. So this is from left to right. And then I'll start writing my function over here. So is it clear?
Yes.
Okay, so now let me then break you out and just two groups. So group one needs to do left to right printing. Group two needs to do right to left printing. So make sure you copy the question, the description from the chat. Just copy that into any text file. And then here you go. So good luck. Then let's see each other back again in about 20 minutes. Okay. So group one, did you figure out the answer?
Yeah, we did.
Would you like to share the screen?
I don't. I'm not. Sorry, I'm using my phone, so I can't really show the screen. I have. I can send it in through the chat though.
Yes. Okay.
All right. So this is our answer.
This is the. Is this a recursive function?
I believe so.
Okay, I've taken that one and I am going to paste this over here. So what is this test collection.end?
So it's it just, since it iterates from the beginning to the end of the list, it's just making sure at the end of the list, in case there's nothing there, it just stops it.
what is this iterator? What is the test?
So that was the function that I had actually done the work on, but the test, it's just I just created a chunk of numbers to use for it. So it was just a linked list of just test variables that I ran because I didn't see a actual linked list name anywhere. So I just created one that said test, and it was just numbers 1, 2, 3, 4, 5, just pointing towards each other.
So are you using iterators and not pointers?
Yeah, but I don't know what you would call it, but like they were so where you have them like in order. I'm so used to calling it pointing that I don't know another term there for it.
Is this the
It was just the name of
name of the?
Yeah, so you should be able to name it whatever it needs to be there.
Okay, so you are using iterators and not pointers, but then one thing that is there is you're calling using the same function, so you don't have a separate public private function. The thing is, what are you calling this iterator with? How are you going to set this iterator to something as the head? Because this thing needs to be called in the main function.
Okay.
So then how would you be, what argument are you going to pass over here?
Well, I called that function I called that in the main function. I didn't call it in the hxx file. So I had it in my .cpp.
Oh, so you had to write a function in the hxx file.
Oh, okay.
Where you can actually call that function from the main.
Yeah, got it. I can adjust it.
Can you make any changes so that would work?
Yeah, so I mean, it would be kind of easy to adjust it there. Then instead of the delinked list data t there, sorry, one sec, I have to pull up the file. Okay, so you would put a type name data t instead of having the delinked list there. So
what should I have over here? I have the type name here.
Yeah, 1 second, and I can adjust this real quick. So it should look like
this should technically be a 0 argument function.
Yeah. I'm just trying to figure out what we would do for the iterator. And then it would look something like this, I think. And then I don't know what would go after the double colons at the top for it.
The double colon.
Yeah, so I mean, it would go colon, and then would it be? Would you put an iterator there? Because that's where my problem's coming in. Is
There is a reason you're using an iterator and not a pointer. Do you find using iterators better than using pointers? You can use iterators, I have no problem, but then a little bit of correct usage is what we need to learn. And I mostly demonstrate examples with pointers. So I'm just wondering, are you more?
No, it's what I saw online for it. Pointers would work just as well. Because I mean, the code kind of works the same way regardless of if you make it an iterator or a pointer. So I guess I could just make it a pointer.
Then how do we make this work? So I'm taking your latest code over here. And let me again copy this to the place over here. This is your latest code.
Yeah.
Again, you're still calling this function with an argument. And this is supposed to be a zero argument function, so we can call it in the main. Then the other functions that we write for the recursive implementations, the reason we have a zero argument for them to be able to be called in the main. And then we pass, because head is not available in the main, so we are setting the head inside and then calling a helper function. But in your case, you're calling this same function, but you have to begin either the iterator or the pointer at the head. But how do you begin this with the head if you cannot access the head in the main function? Because it's outside. Head is private to the class. Do you see what I'm saying?
Yeah, I don't know how to answer it.
All right, so we'll come back to this one. Group 2, what do you have?
Yeah, so I'll post it. I get errors when I try and run it in main, but this is what we came up with.
And this is the reverse list?
Yeah, this is reverse. So it points to the previous. Oh, that should be tail. The pointer should point to tail, not to head.
So let me again share the screen, and now let me comment this one out for now. And let me just try to is group 2's code over here.
That should right there with pointer, it should be pointer underscore tail.
This one?
Yeah.
And tails previous. Why do you have tails previous?
Well, we want to print backwards. Oh, it should just be one previous, huh? I wanted to skip that last node because that node's the dummy node.
The dummy node is just the tail. Tails previous is the actual list.
Oh, okay, so there should just be one previous then.
One previous. And then group 1, do you see we have a separate function? And inside the function, either using iterator or using pointers, we are sort of like be able to call a helper function. Okay, going from there. Okay, here you are passing this. So you need to receive this, right?
Yeah. Well, maybe that was why it wasn't working. I was trying to find why it wasn't working.
And then you say return previous point, return. Okay, let me just first copy this one here. This is a helper function, so I'll just put this in my private section here. Okay, and then we have the Okay. Now, these are using just simple pointers. So what this one is doing, just calling, setting it to tails previous. That's the last node of the list. And then calling it and checking whether it has reached head, returning 0, printing it, and then again calling it. So let me try to run the call this first in the main. And then call the, what's it called? Print reverse. Let's try to run this. So there are some problems here. Void function int. Void function returning a value. Print R reverse is a void function. Print R reverse is a void function. It's a void function. And it's returning a value here. That should not be the case. Then
Yeah.
3 to 10 1. So this one is reversing. One more thing. And not size t, you can make this function void. You can do an empty return, not return anything, just that is an empty return. That would work just as well. And you could simply call this just without return, just doing a simple call. Let me change this. And let me try to run this. So this works, right? So you could either have it return a size t and just return 0 that you did earlier, but you can also make it just a void function, which is just similar to the actual public function, not having it return anything. And if you want to return, because you want to be able to end the function call, so you just do an empty return over here. You can do that. This matches with the void. And instead of returning anything, you can simply call the function, like how you called this function over here.
Where did you include your the function header for the print reverse helper?
I included it in my HPP file, but in the private section.
Oh, does it have to be in there for the node to be recognized?
Which node? Which,
The function argument, the parameter.
this one?
Yeah.
I mean, does it have to be in the private? Can it be in the public? That's what you're saying?
Oh, it has to be there because that's where the struct node is declared, huh?
No. It can be also a public function. You can use node star in here as well. That has not got to do with it. The thing that we are making this a private function is that we don't expose this function, this helper function, to the main. Because you could have straight away, like what the group one was doing was writing one function instead of two. So we could have actually clubbed both of these functions in just one. We could just have not have this function and simply, call this function again and again by simply just calling with tails previous this function by node star over here and then calling itself. This function is not supposed to be exposed to the main. That's why we make it private. That's all.
But if you put it in the right there where it is, like if you move that declaration to line 42, it's not going to compile. It's going to say that it doesn't recognize the node.
Yeah, yeah.
Or if I move it to,
line 42.
Like if you put it in the public, because the node hasn't been declared yet.
So it's gonna say the node is it won't recognize node, or it will just complain that about
or
node.
there is no forward declaration for the struct node. That is why. Well, here's the thing. Is that what it's saying? Oh, is that why you were saying that? Okay.
Yeah, that's why I was like, I was confused because that was one of the things that was confusing me. But now I understand why.
Hold on just a second. It's not using the nodes anywhere else, is it? How else is it setting all of these stuff over here? We have node here. The thing is the declaration. It's the declaration. You see what we are doing over here is like, we use iterators here, right? But we actually define the iterator down here. That's why we use a forward declaration here. So to be able to use the node here, you could, it's a private, you could, that would make it public. Oh, what you can do is like, make this, it doesn't have to do anything with the public and the private. It has to do it being declared before or after it. So if I move this private section, cut it from here and move it just, this is the best place to put it, over here. Before anything, here. Now, even though I don't put my reverse helper function, it's not private, it's still public because it's in a public section. But node has been defined before it, so now I can actually call it. You see what we did?
Yeah, I understand now. We could also have like multiple public and private sections, right?
Multiple public and private, never seen that. I mean, like 2 public sections, 2 private sections in the same class? I don't think so.
I imagine it's probably bad practice, but I mean,
I've never seen that, having 2 public sections, but put everything public in the public section, everything private. Its only thing was because the private was being declared after everything, and you were calling the node start before its declaration. That's why I didn't recognize this over here. But this is currently a public function, and this is something different. If I put it now in the private section, that makes it a private function. But if I put it in over here in a public function, like right the first one here, that means that this has seen node because node has been declared before. So I can very well do that, make this a public function right here. Okay. But the whole point is this is actually a private function because this is not supposed to be exposed to the outside of the class. That's what the main thing is. But coming back to what we had for the group 1. Now, can we come back to group 1? I think it was Nathan.
Yes. So I took group choose function sort of as a base for it, since keeping it with pointers actually does seem a lot easier.
It seems a lot easier. And I think you can do it with iterators as well, but just takes a little bit more time to.
Yeah, but you'll end up with something like that, which I just put in chat.
Okay, let me just take this one here.
And that has reverse helper at the end, which we want to get rid of that.
But you still don't have a separate reverse function, helper function. You have to have a separate helper function.
Oh, okay.
Like
sorry,
we have a separate helper function for this one.
Yeah, so I can make it a separate helper function.
Do you need to make a function named helper, or can you just overload the function?
You can call it any other function. Again, this one, this argument will go in the helper function,
Okay,
not in the public function.
got it.
We need to have the declarations, the headers in the places of again, we can just have this one as void, not really wanting to return a size T out of it, simply returning, just doing an empty return. So you're beginning from the heads next, and they began from the tails previous. Yeah, that's what we had to do. Then we call the helper function, and then we check it till the tail. You just do an empty return, and then you do this, correct? Let us now call this again. And let's try to print this out. So there you go. I mean, you can still try to use the iterator, just have still two functions, one public, one private, where you are, instead of the pointers, you are setting the iterator to point to the head next and then going one by one, just changing everywhere here, iterator, and then just printing how you would do with iterators. You have to do a star IT and then do an IT plus plus to call the next, right?
Yeah, so I mean that would work. I'm just not terribly familiar with iterators. It's just what I saw online when I looked for an example of sort of how to do it.
Okay. But is it clear now, everyone, what we are doing over here? I will be posting this code later on, but is it clear? Any questions?
So because I've done iterators and other, I meant recursive functions in other classes, and we just did the whole case structure in a single function. But is it better practice to have a helper function instead of giving the entire job to like a single function?
It's a better practice when you're, yes, because our head, tail, node, all of these things are private. So these head and tail are something that are private data items which are private to the class. Only the functions can access the head and tail. You do not give it to the client code. This is the client code. If somebody, any user, were actually able to access the head and the tail, then they can actually change the code of your functions. I mean, think of it like a list that you have created, a list of records. For example, you have a directory of phone directory for Fullerton, and you have a linked list already created for it. Would you like to give the head to any random user? They will then just change the list. They will actually even delete the list if you give the head to them or the tail to them. It's something that you keep it with the people who are maintaining the code, not the user who are using it. The user may still want to be able to access the functions by trying to print out or, okay, maybe able to add to the list by giving the functions that are, because you are making publicly available those functions to be able to add to the list. So maybe if the user wants to add themselves to the phone directory, they will say append, and then they will put the information in it. But if you give the head of the tail, head of the list to any user, to maybe a new person who comes to live in Fullerton, then they might even erase the entire directory. You know, they will say head is equal to null and your list is gone. So would you want to ever do that? No. That's why we keep these things private. And we only expose those functions to the user which they cannot sabotage the actual data. The actual data is available with the head and the tail, and these functions are able to use the head and tail to manipulate it, but only functions which are logical. You can add to the list, you can delete to the list. Those you are making available of your own volition. I mean, you are saying that I make these functions public, but you can also not make all of those functions public. Maybe you can just, add more functions where you can check the user that has the user tried to append more than one time. Don't let them. So you can add one more function that can actually check how many appends somebody is allowed. But the master list is just staying hidden from any and every user. If you give them these are the main data items that are actually, tagging your list with the head and the tail. If you give them that, they might be able to sabotage, change, delete that list. And you should never want to do that. And the reason why we have two functions is we never expose the head to the user. This is the user code. You never expose the head, but you need the head to go to the next location. And that's why and a recursive function needs to call itself. It needs to call itself. It needs a pointer to be able to be updated. And if you don't give the head, then you need an intermediate function to set the pointer to the head. That's the job. So was that clear?
Oh yeah, that makes sense. I've never done it where I've had to worry about end users potentially doing stuff. So this is being aware of what's private and public is new.
It's very important. Yes. Okay. So all right. So let's wrap up then, and then meet again on Thursday. Just remember the deadlines for the two upcoming homeworks this week. All right. So that's about it then. Bye everyone. Bye for now.